I don't get this.
All right, so 2, 6, again, I said it yesterday, but we're kind of like baby stepping our way into proofs. So this one gave you the diagram. Well, it didn't, but I added it on. MATH is the segment that's labeled there. And then it said that you're given MA equals TH. So if you want to label on your diagram, which I would recommend, MA is congruent to TH. And then you want to prove that MT is congruent to AH. But again, look at my diagram. Does it make sense that MT should be congruent to AH? And why? Math. Why? Why are those congruent?
It's the same.
Because since T and H and M and A are congruent, then it's kind of like
It's like logical.
Yeah.
This is logic.
Okay, so if I had to say, what do you mean by logic? What would you tell me specifically for this one, without all the statements and reasons? Why would those two be congruent?
Okay, so if the distance between, let's say, M and A is, I don't know, 5.
Okay.
And T and H is 5.
Okay.
And then there's something in the middle. I don't even know. Something in the middle.
No matter what that length is in the middle, you're adding the same length onto both of those 5s, yes? Okay, so you're adding the same segment onto both parts. The both parts we already said were congruent, yes? You're actually very much on the right track, okay? That's why, yes, it should make sense. If I am taking the same thing and adding it to parts that are already congruent, then those new segments should still be congruent. So number 1 gives you that MA is equal to TH. What is that? Given. Okay? Number 2 says the reflexive property of equality. What does reflexive mean?
The same.
Anything equals itself, okay? But like, why would that be there? We probably have to look at 3 first. What do you notice that's happening in 3? You're adding AT to both sides in 3, right? So AT equals AT makes sense because now I want to add the same thing to both sides of my equation. Does that make sense? If I look at 3, right? If I look down here and I compare 3 to 1, what did I do? I added the same thing to both sides of the equation. So the first thing it's doing is I'm establishing that those two things would be the same whether I add it to the left side of the equation or the right side of the equation. That's the reflexive property. Now, what happened to 3? Which is what? Good. Addition.
No, you said it was substitution.
Property of equality. So, I remember I said you could also do POE, but addition, property of equality. You added the same thing to both sides of the equation. Now 4 says MA plus AT equals MT, and AT plus TH equals AH. What is that? Good.
There's a pause.
Because we're using the picture to say that MT is the sum of MA to AT, and that AH is the sum of AT to TH. So then 5 is the substitution property for the reason I should already know what that should be, right? What's that? MT equals AH. Because we said here that MA equals AT, and then we said here MA plus AT equals MT. So we took in place of the MA plus AT and put MT. And then here we said that equals AT plus TH. And here we said AT plus TH equals AH. So we replaced that with the AH. That's substitution. All right, this one says, use the given information to prove the statement. There's no statements here. This is so scary, right? So let's start with what we're given. We are given that the measure of angle 1 plus the measure of angle 2 equals 90 degrees. So I'm going to make that statement first. 1. Measure angle 1 plus measure angle 2 equals 90 degrees. 1 given. What else is given? Measure of angle 1 equals 59. We can put that together in one statement because they're both the same reason, or you can separate them out and say 1 and 2 both have given. Doesn't matter. Both are correct. Okay, so now this is 59. That's what we know from this. And we know that these add up to 90 degrees, right? So how would I get that the measure of angle 2 is 31 degrees?
Substitute 2 the 59. Measure 1.
So 2, I can say the measure of angle, or not the measure of angle 1, I can say 59 degrees plus the measure of angle 2 equals 90. And that's substitution.
Substitution.
Now what?
Subtraction.
And I get the measure of angle 2 equals 31 degrees. Subtraction, property of equality. How many we got right? Out of curiosity. Okay, pretty good.
I put 50. I did the
actual step, like minus 59, minus 59.
And
That's
then
fine.
yeah.
Well, so you can't do 90 minus 59.
What do you mean? Like, show that step?
Yeah. Well, can you do that instead of doing using the measure of angles?
Eventually, oh, you moved the 59 to the other side, you mean?
Instead of doing 59 plus the measure of angle 2
Equals 90. You did what?
just 90 minus 59.
You'd have to show how you came up with that, though. Questions? Okay, so this test, good news, is you're going to get statements. You have to fill in the reasons. Next test, bad news, you're going in blank, folks. Okay? You're going to be able to do this, I promise. When we get to chapter 3, you're doing like parallel lines, that kind of stuff. Eventually, you're going to get there. Sometimes it takes till like, I don't know, November to get a completed one all by yourself, but you will get there, I promise. Okay? Don't get frustrated yet. And again, if you leave it blank, I should be able to like beat you over the head with your own iPad. Do not leave it blank. Come up with something. Start with the given and see what goes from there. Okay?
We're doing like math with like numbers.
We're going to do math with numbers. I mean, you're kind of infusing math with numbers in here, but it's like this for a lot of the year. Yeah. Okay. So, actually, chapter 2, section 7 is the proving angle pair relationship. So we're going to learn a couple of things about angle pair relationships. This is the last section in the chapter. Okay? Yay. And then we're done. So over the weekend, I'll actually, I think I just published it. Your test review is there so you can get a head start so you're not doing all of that Monday night. The Quizlet after today, God bless you. After today's, the Quizlet will have everything from chapter 2 on that. So it's a good thing to practice. It's got all the properties, all the definitions, all the theorems, all that stuff. Okay. And then on Monday, we'll go over the review. And again, test will be Tuesday. All right, so right angle congruence theorem is a name of a theorem. So remember we said postulates were numbers and the numbers didn't matter? Theorems that have names, the names matter because it's basically your shortcut to having to explain the entire thing. The right angle congruence theorem says all right angles are congruent. Now, this little guy is trying to prove that. So it says, given angle 1 and angle 2 are right angles, prove that angle 1 and angle 2 are congruent. So we're going to actually practice a proof by proving what we already know, okay? Number 1 says angle 1 and angle 2 are right angles. What's the reason there? Given. Number 2 says the measure of angle 1 equals 90 and the measure of angle 2 equals 90. How do you know it's substitution?
Because they're right angle or right angle.
So it's because you know what a right angle is that you know it's 90, right? Which means it's not substitution, it's actually the definition of a right angle. So if someone had no idea what a right angle is, they would not be able to get to that step, right? They need to know that it's a right angle. Now C says the measure of angle 1 equals the measure of angle 2. What'd you do there? I think it's so hard because it looks like it's transitive, but it's a value, which means it's substitution.
Wait, how's that substitution?
Because 90 equals 2, you took 90 here and replaced it with the measure of angle 2, right? If you replace a value or a value replaces an angle, if there's a value involved, it's substitution, even though it looks almost exactly like transitive. If that had said the measure of angle 1 equals the measure of angle 2, and 2 equals 3, so 1 equals 3, that's when it's transitive. We're talking about all objects.
Yeah, I get
All right, and then D went from equals to congruence, which is definition of congruence. We go from equals to congruent or congruent to equals, and that's the definition of congruence. The good news is you will never need to do that proof anymore because now we have something that says angle 1 and 2 are the right angles. Prove angle 1 equals angle 2. It takes one statement, and that is the theorem, that the right angle congruence theorem. Okay? So now I can go from here to here with my given, and then my reason would be the right angle congruence theorem.
So that's all you're saying?
Yep.
So, nice.
Okay. Or you could go through these steps if you don't remember the right angle congruence theorem, right? It's just extra steps. It's still, they're both still right.
So we can do that whole thing.
Sure.
Or put the right angle.
Yep.
Okay. I'm probably gonna end up doing that.
That's fine. It's still right. All right. Congruent supplements theorem says if two angles are supplements to the same angle or to congruent angles, then they are congruent.
Oh, so since they all equal 180, like, so 1 and
So think about, go ahead, describe it.
so like, since 1 and 2 equal 180,
Yep.
and then 2 and 3 equal 180, it's like the transitive, so like 1 and 3 equal.
So if 1 and 2, yes. If 1 plus 2 equals 180, and 2 plus 3 equals 180. You with me so far? Then I can actually say 1 plus 2 equals 2 plus 3. Why is that?
Because they are
They're
congruent.
They both equal 180, right?
Yeah.
And if they both equal the same thing, can I replace 180 with the other half?
Yeah.
Yeah.
What's that called?
Substitution.
Substitution. So I can substitute 2 and 3 in for 180, yes? Now what could I do with both sides of this equation? Subtract off angle 2.
Transitive.
I can subtract off angle 2. Subtraction.
Just use the,
And then
like if they
congruence.
say,
Definition of congruence.
And then if I wanted to go to congruence, I could do definition of congruence.
can't instead of like subtracting it, can't you use the transitive? Because
No, transitive would be if 1 equals 2 and 2 equals 3, then 1 equals 3. That's if and then, right? So now, again, you can go through that process every single time if you don't remember this theorem. Or you remember this theorem and it says congruent supplements theorem and you know that that's true. If two angles are supplements to the same angle or to congruent angles, because there could have been another angle in here, like 4, and I could have said angle 2 is congruent to angle 4, and then all of this would still work because I could still link 1 and 2. Yep.
So typically would say so and so or supplements.
So the result, the given would be 1 is supplementary to 2, 2 is supplementary to 3. The proof would be 1 is congruent to 3. The given is given. The proof would be congruent supplements theorem, the reason. And this is what we just talked about, right? So if I had a given that said 1 and 2 are supplements and 3 and 2 are supplements, I want to prove 1 equals 3, or 1 is congruent to 3. This is what we just said, right? Now it's in specific statements. So what's 1? Angle 1 and 2 are supplements, 2 and 3 and 3 and 2 are supplements. Given. 2 says the measure of angle 1 plus the measure of angle 2 equals 180. The measure of angle 3 plus the measure of angle 2 equals 180. Just like throwing out words. Definition of. Did you see the word straight angle in there? Supplements. Good. Three. 1 plus 2 equals 3 plus 4. 3 plus 2. What's that? Substitution. We replaced 180 with what 180 equals. Substitution. 4. The measure of angle 1 equals the measure of angle 3. Subtraction property of equality. And 5. We went from equals to congruence. Definition of congruence.
In the test, only the reasons that we need.
For this one.
Yeah.
For this one.
A test after that.
Mm-mm. Okay, so again, if you in the future went to go prove this, you could choose those steps because they're right. Or shortcut it and say the congruent supplement theorem. What?
Like if they had that.
If it just said this at the top, you could go through all these steps because it's right. Or you could go from the given, the reasons given, to the prove, and the reason is the congruent supplements theorem. That's it. Yeah.
I'm just curious, why does he have to?
Like this specific thing? Do you want to do good on your test on Tuesday? Yeah.
Well, besides that.
I mean, maybe you're going to be a 39-year-old lady that teaches it and you didn't even know you were going to be teaching it, and that's why you need to know. You never know. One day you'll be walking down the road and somebody stops you and is like, what's the congruent supplement theorem? And you'll be like, I know this. And then they give you $1 million. All
That's never gonna happen.
right. Yeah, right. All right, congruent complements theorem.
I'd be sad if I did.
Says the same thing except for complements, right? If two angles are complements to the same angle or to congruent angles, then they are congruent. So same exact concept, except now we're talking about complements instead of supplements.
So it's 90 degrees.
So in that diagram, if the measure of angle 1 and angle 2 are complementary, and angle 3 and angle 2 are complementary, then angle 1 equals angle 3. Then that's supplements?
I like this better than the
Then-
going through all those steps.
Oh.
I guess-
Con.
What if they do like 89 years? They wouldn't be able to tell. They just know.
It has to tell you. It has to either tell you it's complementary, or you'd have to have a right angle or something. It has to say that. Yeah. Or it says it's 90. It can't look like it. All right. Linear pair postulate. So we talked about a linear pair. Linear pair is two angles, right, that form a line. Now we're giving it a name. If two angles form a linear pair, then they're supplementary. So you're just getting a name for it. Okay? The linear pair postulate, or LPP, like we'll simplify it a lot of times, is that two angles that form a line or form a linear pair are supplementary. And if they're supplementary, what does that mean? 180 degrees. Okay. Linear pair postulate. The vertical angle definition we know. It's two angles such that the sides of one angle are opposite rays to the sides of the other angle. So we already know the definition. So in this diagram, angle 2 and angle 4 are vertical angles, and angle 3 and angle 2 are vertical angles. If I extend the sides of one, they become the sides of the other. Okay, now we have something called the vertical angle theorem. And the vertical angles theorem says vertical angles are congruent. So the definition is just that they are vertical angles. The theorem says that they are congruent. So every pair of vertical angles is congruent to each other. Definition is just that they are vertical angles. Like angle 2 and angle 4 are vertical angles. That's based on the definition. But angle 2 equals angle 4, that's based on the theorem. So we will also abbreviate this a lot to VAT, okay? Vertical angles theorem. All right, let's see if we can prove the vertical angle theorem. So this says, given angle 5 and angle 7 are vertical angles, prove that angle 5 is equal to angle 7 without using the vertical angle theorem. So we're going to prove the vertical angle theorem. What would be 1? Angle 5 and angle 7 are vertical angles. Given. Number 2 says angle 5 and angle 6 are a linear pair. Angle 6 and angle 7 are a linear pair. Good. Definition of linear pair. Three says 5 and 6 are supplementary, 6 and 7 are supplementary.
Or you substitute
So close. You're one word off. linear pair postulate. Okay? We know that they are supplementary because we have said that linear pairs are supplementary, right? So that's linear pair postulate, or LPP, linear pair postulate, which says that if two angles form a linear pair, then they're supplementary. If I substitute 180 in for supplementary or supplementary into 180, that's the definition of supplementary. But if I say that they're a linear pair, so they're supplementary, that's linear pair postulate.
Equals. When it's supplementary, that's linear pair postulate.
So if you're doing linear pair to supplementary or supplementary to linear pair, that's the linear pair postulate. When you're going supplementary to 180 or 180 to supplementary, that's the definition of supplementary. But now we're saying what's happening in 3 is that we've just established that two angles are supplements to the same angle, right? What is that? So you can't use substitution or transitive with words. But look back on the things we talked about today. We had something that said if two angles are supplement to the same angle, then they're congruent. Now, if this was open-ended, then I could have gone from 3 and said angle 5 plus angle 6 equals 180. Angle 6 plus angle 7 equals 180. And that would be the definition of supplementary. Then I could have said angle 5 plus angle 6 equals angle 6 plus angle 7. And that's substitution. And then I could say angle 5 equals angle 7, subtraction. Property of equality, angle 5 congruent to angle 7, definition of congruence. So if it was open-ended, there's more than one way to do those. Like you can't freak out if you're not doing them the exact same way as somebody else. If there's steps, obviously they should be the same.
Are you gonna want us to do a specific way?
Nope. Whatever you know the best, whatever clicks for you, it's fine. Sometimes people get competitive and they want to do it in the least amount of steps possible. As long as it's right, I don't care how many steps it is. Okay, last thing, just says classify each statement as true or false. So 1 says the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. Then angles A, B, and C are supplementary. True or false? Oh, this is such a trick question. It's false. Do you know why?
Let's see, these angles can be
Good. It's false because supplementary comes in pairs. It's two angles that sum. Okay? Do you have like an alarm that's going to go off at the end of the 7 minutes, Jack? No? Okay. Oh, just, yeah. Yeah, no, I figured what it was. All right, 2. Vertical angles have the same measure. True or false? True. We said vertical angles are congruent, right? 3. If the measure of angle 1 and if angle 1 and angle 2 are vertical angles, then and the measure of angle 1 is 2x plus 8 and 2 is 3x plus 4, then x equals 14. How do we figure that out? Set them equal to each other. So if they're vertical angles, then they have to be equal to each other. And then I would solve. That would be my subtraction step. This would also be subtraction. And I get x equals 4. So is it true that x equals 14? Nope. Okay, x should equal 4. Questions on anything we talked about today? Okay, so that wraps up everything that's on your test. So there's a Quizlet that has all the theorems and postulates and definitions. Okay, there's the review from your book and the answers to it. So take advantage of all that stuff on top of obviously the 2-7 homework, which is going to be extra practice on proofs. I'm going to